Good afternoon and welcome to the Aviation Technology Connect webinar series at RTCA. I'd like to welcome you to this, our second webinar of 2024 for a very exciting topic. It's not a new topic to RTCA. As some of you know, last November, RTCA hosted our first in-person workshop on artificial intelligence and machine learning, and we were joined by over 100 participants, both in person and online. Presentations were made by government and multiple government agencies, including the Department of Transportation, FAA, NASA, U.S. Naval Research Labs, as well as members of industry to start this and continue, I should say, this important conversation about standards and safety with artificial intelligence and machine learning. I am pleased today to be allowed to welcome Dr. Trung Pham, FAA's Chief Scientist and Technical Advisor for Artificial Intelligence and Machine Learning. Welcome, Dr. Pham. We really appreciate you being here.
Thank you, Rebecca. As you know, the FAA just released the first official copy of the AI roadmap, and I'm very happy for the opportunity to share that roadmap today.
We are so happy to have you here sharing the roadmap with us because the conversation started before the roadmap, and I'm hoping it will continue through the roadmap and future updates as we see where artificial intelligence takes us. So I just want to let everyone know this is only the first of two artificial intelligence machine learning conversations we have planned. Today, we're starting with this presentation from Dr. Pham, which we're all excited to hear about and really appreciate the FAA releasing the roadmap this month. But then on November 13th, we're going to host a second in-person workshop here at RTCA. Dr. Pham has agreed to join us with that along with other members of industry and regulation. So I hope you guys will mark your calendars and join us here too. Dr. Pham, why don't you give us some background on your paper? And I know you have a presentation for us to kick us off, and then I'm sure we'll have plenty of questions for you.
Thank you, Rebecca. So today I would like to share the basic information of the roadmap that we developed at the FAA, and the agenda is simple. We just do a quick introduction of why we had the roadmap, and then I go directly to the roadmap that we release the basic information. And along the way, we like to share with the audience about the challenges that we have encountered when we are trying to address AI in aviation. And then once we went through some of the basic challenges, I hope that we will have a much smoother path moving forward with the next step. And then I like to open for discussion at the final. As we know, artificial intelligence, by definition, this is a very old definition that I learned in my AI class 40 years ago. It's a discipline of mimicking human intelligence on computational machine level. So that was a fundamental definition. Since then, we have much better definition, and the one definition that we are using on the roadmap is based on the executive order on AI that we have. That focus is more on specific tasks that AI can do. But as for this point, we want to mention that AI has been creating a lot of excitement and fear from the public as well as in the regulator and developer. And there is an important concern about this path to the aviation sector. For excitement, we see many possibilities of using AI to make it easier to fly or operate an aircraft. But for fear, we saw a lot of hype about AI, what it might be able to do, that create a lot of fear. For example, the capability to gain consciousness and to have independent moral compass. similar to what we have been seeing in science fiction movie. But we know that there are so many applications to using AI in aviation that there is interest to have a path to certification of this technology. So in 2020, the REGAC SAS subcommittee recommended the FAA to work on AI assurance in aviation. And in early 2023, we presented the work plan to REGAC SAS about how we are going to work on the AI roadmap. And after we got approval, we spent much of 2023 and part of 2024 organizing many technical exchange meetings to have conversation with the industry so that we can have all the input and recommendation into the roadmap. And we also share the progress of the development of the AI roadmap to create a common expectation of when it will be finished. In August 2024, we released the first official version of the AI roadmap. So in this document, we talk about many things concerning AI in aviation, but I can summarize that into a few key points here. Number one, we want to begin with the focus on the onboard software. Even though we are not going to restrict ourselves to this domain, we just feel like that by working in one domain at a time, we will gain much better understanding of the technology before we move on to another domain. We identify many guiding principles, things that are independent of the technology, independent of the people involved in the process to help us shape the path for AI to move forward. And in the background, we are going to do supporting research to help us with the path to certification of AI, mainly to assure the safety of AI. And at the same time, we begin to consider using AI in the future for safety. So the important key thing about the roadmap will be the list of guiding principles that I like to elaborate a little bit more. The first one is the focus on safety. This is a very important aspect for us because we at the FAA only have the authority to regulate safety. So you might have seen all the aspects of AI being mentioned from the executive order, which I will elaborate more later when we put the AI roadmap in perspective with respect to all the AI strategy and AI executive order. The second one that we like to mention is we do not want to personify AI. At the beginning of working on a roadmap, we heard a lot of discussion about AI and specifically about machine learning, and the way it was described to us was somewhat misleading because it's describing it in the context of human learning, which is some different from machine learning. So at the beginning, I want to focus on AI, where machine learning is one aspect that people use to train a model to do a function. So we want to focus on machine learning, not human learning. So I wanted to talk about not personify AI, but it turned out the conversation within the FAA evolved to the point that we are seeing AI as an engineering component that will be implemented in the aircraft. And from that aspect, everything is consistent with the remaining of the guiding principle that I will elaborate more. But mainly here, we don't want to make it not clear about who is responsible for what. If we see AI as an engineering component, then it's the developer who will be responsible for that component to put into the aircraft. And the conversation was also about the research state of AI, where most of the researchers will be focusing on the capability to continuously learning even after some training. But what we saw from the aviation application is that there is a class of AI system that we call learned AI, the system that people train and then lock down, and it will be 100% deterministic. And that's make it a lot easier to see as an engineering component that we can figure out how to assure the safety of that. One of the things that we had in the conversation, both with the industry and with the FAA, is that we have a good record of safety, and that was built on existing regulation for the past many years. So the important key point is to try to use as much existing regulation as possible. So here we're looking at AI system as a piece of software that we mentioned at the beginning in the traditional definition of AI. So we are looking for applicants to comply to something like software development assurance that we already have in place and have been in practice for many years at different level of item system in aircraft. And we don't claim to understand AI completely. So what we like to do is to do the incremental approach, to go from specific projects to have better understanding before we can generalize that into something more broader at the policy level. We are going to go from simple project to more complex project. And we are going to go from low level criticality to high level criticality on the safety continuum. And the most important thing that we want to emphasize is the collaboration between the FAA and in the industry. You might have seen us elaborating with the industry in many projects that we presented in our technical exchange meeting, and I will go back to that point later on today. For these background supporting research, we see that AI is an important technology, but like everybody else, we don't have unlimited resources. So the strategy is for us to collaborate with all the government agencies to make sure that we can go further, faster, and by not duplicating effort. And on the right-hand side, you see the expected outcome. So what we are wishing for is some guidance for low level of criticality like Dow D or Dow C in the immediate future. And we want to move up to Dow A, which is the highest level of criticality in the near future, as soon as we have better understanding of the AI technology and how are we going to assure the safety operation of this AI system. And in the background, as I mentioned earlier, there is a learning AI system that keep on learning and evolving. And this is where we think that it will be the future in more than 5 years from now, but we have to prepare ourselves for that future as well. In this conversation with the industry and with all the stakeholders, we see that at the top, there is an AI executive order coming from President Biden last year, and it covers a broad spectrum of what is relevant to the use of AI across different government agencies. So that is a very comprehensive direction. But going to the right-hand side, you see the FAA roadmap for safety assurance that I just mentioned, where we only focus on AI in aviation, and that doesn't really concern many aspects of the use. For example, in the AI executive order, we talk about using AI for criminal application, which is completely different from using AI in aviation. So some of the concerns there are valid, but not applicable to aviation. So we want to focus on safety only, the first guiding principle that we mentioned. And at the FAA, we also have the FAA strategy developed so that we can comply with the AI executive order. And some of that will be channeled to the roadmap. Some of the key is the use of AI for safety. That's the long-term aspect of using AI I mentioned earlier. But it's also talk about the building up the FAA capability. We encounter many challenges when we talk about AI in aviation, about safety for AI. One thing that seems to be obvious to everybody is the lack of unified terminology. So we see everybody, when they work on AI, they have to work with the people in the industry where the use of the trade jargon became a regular thing. And if you saw people working on AI, you would see that the first thing in their document is the definition of those terminology. That's just see what they mean. And I am an open-minded person. As long as we have the convention to communicate, to say that this is what we mean, I think it's a good achievement to move forward. But sometimes people might be using the existing engineering terminology for different things. So it can be confusing if we don't go back to the definition of what we mean, what he means, or what she meant. So this is a very confusing situation right now. And you saw that when I reported to REGAC about the work plan for the AI roadmap, I try to promote the use of engineering terminology so that we don't have to reinvent terminology or to cause confusion, because the key idea is to reach the engineering community in aviation without forcing them to learn AI-specific terminology. And another challenge that we saw is the lack of explainability. And this is about the developer unable to explain the functionality of the system that he or she developed. And sometimes it's the lack of system engineering, and sometimes it's the path going directly from data through training to system that prevented the clear explanation of the functionality of the AI system. But we believe that it can be fixed in an engineering context that I will explain later on. And in software, if we look at the software development guidance, there is an important aspect of traceability to go from codes to the requirements. And there is a lack of connection. There is a lack of connection between codes that are generated automatically by the training software and the requirement that we imagine would be applicable to the aviation scenario. The third challenge that I like to mention is the introduction of the new technology. We know that in academic, AI has been around for many years, but to the public, AI was introduced recently, and as just like any other new technology, we see different expectation of the new technology. So you see here is the curve that we call the Gartner curve of new technology. Our chief scientist in human factor, Dr. Kathy Abbott, showed me this curve when she worked with me on AI and automation roadmap. So the key thing on this curve is that at the beginning of the technology, we have high expectation of what it will do, but in reality, it's less than that. So in this curve, I believe that we are on the horizontal timeline. We are right here near the top of the peak of the inflated expectation of what is AI. And at this point, the unrealistic expectation of AI can lead to over-regulating of AI. We think that we don't really want to put a burden to the industry that might prevent innovation. So the question that we are trying to do is to go from where we are now to the plateau of productivity in a peaceful manner so that we can get to the point that we can be more productive, both from the developer point of view and from the regulator point of view. So you see, we have the roadmap finally released in August, but it's just the beginning of an exciting journey. It means that we have a lot more to work on. But right now, with the current understanding of AI and machine learning, what we see is that AI ML is implemented in software, so that is consistent with the initial definition of AI when we mentioned that it's mimicking human intelligence at the computational level. So it means that it's implemented in software using traditional computer programming language. It will be run on a traditional computer system. So what we are seeing is that it should be following existing guidance, the guiding principle that we listed in the roadmap about trying to use as much existing guidance and regulation as possible. So here is such as software development assurance. We also know that AI ML is developed, the system is developed differently from traditional development of other engineering system. So we think that maybe that additional guidance will be needed. We are here to share all the understanding that we have going through many projects that we have at the FAA to the community for this effort. So as you see, for the past 4 or 5 years, we see the discussion that there is, if we can separate the AI model from the software implementation, then things would be clearer. And going through different projects at the FAA, we see things clearer, and we see it's a simpler two-step. First, we look at the model development, and we look at it from different perspectives. We look at it from the software perspective, where DO 178C mentioned a model. They mentioned the computational algorithm, which is exactly the implementation of the mathematical formulation of the model. So we see that, and we ask ourselves if we can do the basic VNV of the model even before the implementation of the software. Would that simplify the VNV of the software implementation? And we went through that, and we saw a lot of simplification, where instead of having to do VNV of both the model and the implementation of the codes, we see that if the model can be verified and validated before the implementation, then when we get to the software part, it's just the verification that the model is implemented correctly. The functionality of the model is already established in the first step. So that is a two-step that we saw in conversation for the past 4 years, and we like to finish up with clear evidence. So the next step, we want to have at the item level some documentation about machine learning, and we want to show that we are not going out of the traditional engineering practice, where modeling has been part of that practice for many years. So we look at machine learning from that perspective with additional guidance from the software development guidance in DO 178C. And the second document that we want to produce is the software implementation of the model, where the functionality is already verified and validated. And the third thing is we want to have documentation showing example of what we mentioned on the first two. A lot of time we found that if we are going through some example, it's a lot easier to visualize the concept that we have on document number 1 and document number 2. And we have mentioned that we have many technical exchange meeting on AI, but in the past, we focus on working with the industry to have the roadmap. Now that the roadmap is finished, we want to continue to develop specifically on the VNV part of the model and the software implementation. So the next technical meeting, exchange meeting, we plan to have at the end of October in Massachusetts. And we plan to have it in hybrid format. We like to encourage online participation so that it can be more productive and more where we have more understanding. But if for some reason people cannot travel, we always provide the online option so that we can have more participation. And the topic of the next meeting is about the use of many use cases, but instead of describing those use cases to show that AI can be used in aviation. We believe we are past that point. Everybody knows that AI can be used in aviation. Here we want to discuss those applications going through the two steps that we described earlier. One is to do the V&V of the model. Second thing is V&V of this software implementation of the model so that everybody can relate to their personal project. And for every meeting that we organize, we also have one session on the research, and we continue to have conversation on the use of AI for safety in the future. So the final point for discussion is that the roadmap is just a starting point that will guide us at the FAA for future action like research, policy development, and standard, and also workforce competence. An important thing that we found is that by working with the industry, we get feedback from everybody, and this is an important aspect to help us to learn and evolve our strategy and plan. So we are learning from the initial projects that we have right now. We learn from the research that we sponsor, and some we are also learning from each other by interacting with each other. So the key thing is that we will work with the technical community for a sensible and feasible guidance and regulation of AI technology, sensible in the sense that it's not overburdening to the point of preventing innovation, and feasible is the thing that whatever we ask for, we want to make sure that it's doable. There is at least one minimum set of means of compliance. And even though in the background, we share with different organizations about future means of compliance. But if we want to have policy for now, we need to have the technology in a sensible and feasible direction so that the policy can be complied with existing means of compliance. So that concludes my sharing of the AI roadmap, and I'd like to thank the audience for this opportunity to share the AI roadmap and some of the future direction that we are planning. And my contact information is on my PowerPoint that we can have more interaction if you are interested.
Thank you so much, Dr. Pham. That was a great summary of the roadmap, and it has generated some questions. I would like to encourage the audience to put questions in the Q&A, even though we may not be able to get to them today. Dr. Pham has kindly agreed to review them and address them for us as we can. Before we get to questions from the audience, I wanted to ask you two questions since I'm the moderator, so I can pick my questions first. And the first one is, I was struck by the concept of not personifying the artificial intelligence as one of the key parameters. And I'm wondering if you could tell us why that was important to the FAA to call out.
At the beginning, when I talked to different stakeholders, people describe AI, specifically machine learning, in the manner very similar to human learning. And I know it's not completely true. When we do machine learning, what we do is that we collect data that describe how a system should behave. And then the machine learning process will generalize the understanding of that data into simple rule. For example, one of the example I learned from my AI class is to look at how people pair wine with food. And back then, everybody will collect data saying this plate should be paired with this wine for a comprehensive list of food pairing with wine. And eventually it got too large that we cannot possibly go through. So what we did was we tried to generalize it into simple rule. And what we accomplished was red meat would go with red wine, white meat would go with white wine. So it's a generalization of the data. There will be exceptional case, but it's not going to be in that generalization. For us human, we tend to generalize things for conceptual understanding, but at the same time, we memorize specific cases. For example, I was learning Spanish when I went to South America. And one thing is to conjugate verbs in every language. So we learn general regular verb, which is this generalization of the data. But at the same time, we remember irregular verb is special cases. And that machine learning cannot do yet. So we want to differentiate the difference between human learning and machine learning. So the agenda is not to personify AI, to create a misunderstanding and heighten the expectation of what AI can do. But within the FAA, the discussion immediately turned into the more regulation about who is responsible for this. So if we personify AI, it might create confusion about the operation of the aircraft, where the pilot might see AI as another intelligent being. And that will create confusion, especially in the extreme case of accidents, for example. So we want to make sure AI is highly intelligent, but it is still a piece of software component, and the developers will be responsible for that piece of software.
Thank you for that. That was a good explanation between, I like the language, because we do have to, humans can learn the irregular verbs. Google Translate doesn't do as well. We do have quite a number of questions, so I'm going to save my other question till the end. The first one is, if possible, what types of AI technology are being considered? Is airborne reinforcement learning and or airborne generative AI being considered, or is only supervised learning type of AI being considered right now? I did see both in your roadmap. Do you maybe want to highlight what you're doing with each type?
Right now, we see the aviation application in the form of supervised learning, where the system is trained with data and the data is supervised in the form of the label of the data that people collected. So that is a form of supervision, and it's a common practice for the developer in the community right now. In the background, the people talk about unsupervised learning. It has a place in our conversation as well. We talk about the learning AI. We talk about the learning procedure to generalize the data into rules, and at the same time, not taking into consideration the special cases that in traditional data analytics, we call them outliers. But with the unsupervised learning, there is a capability to identify those isolated cases so that we can figure out how to do them separately. So we talk about unsupervised learning in the context of data mining and clustering data. But for now, we focus on what is immediate in the aviation industry, the things that will be needing regulation in order to be implemented into aviation, into an aircraft. So that's the first step, but it's not the only step.
Thank you for that. So this was an interesting question that I have heard before, which is the statement, learned AI is nothing more than predefined control law, I assume. Can you please differentiate?
Well, when we talk about control, we went through the whole engineering practice of control theory, where we have better understanding of what is a system, how that system is represented in the form of the physical law, for example, electrical circuit or mechanical system. But we have clear understand, we have clear formulation to represent that behavior. For AI, we don't. We only have here's the data, here's how the system would behave when given this input, and the input can be expansive, and the data is in many dimensions beyond the 3 dimension that we normally can perceive with human perception. And in the control law, we talk about PID control with only 3 dimensions.
Yeah.
So that's very easy to visualize, and it's supported by known physics. But in AI, there's no known physics in the background. So it might look the same or similar in the final stage, but the difference is that for control law, we can see the development from the beginning to the end, and every step we can verify with the engineering understanding. But for AI, we don't have that connectivity. We just have at the beginning, here's a set of numerical data, and here's the end, we have the model that is computationally similar to the PID controller, but in between, we don't have anything to help us the way we look at the control law.
That was a great explanation of that. Thank you very much. And known physics helps us all, but that's not what AI is. Okay, so want to be sure I'm getting these in the right order. This is a question about RTCA DO330, which is the tool qualification guidance. So of course I'm going to pick that one. He asks, isn't code that's automatically generated also covered by RTCA DO330 tool qualification? ACGs are covered in RTCA DO330. So is what's in 330 enough right now? DO330 and the tool qual?
When we look at AI, we saw the conversation with the industry about what are the gaps that AI created that the existing regulation cannot handle, so that we can elaborate more on the guiding principle of using the existing guiding regulation with some additional guidance. And that's the objective of the conversation for the past 4 years. And when we look at the codes generated from the training software, that question came up. And the idea that we like to have is full conversation with RTCA, with all the standard authority, and with the industry to consider if it's got a gap. And if there is a gap, we are here to share our understanding about the codes. And those are the understanding that we are going to document in the 3 documents that I mentioned. And we'll hope that the industry can use that to consider how it's applicable to GEO 330.
Great.
And one of the things that we also notice is that the training software are not unified,
Mhm.
just like the computer compiler that we had 30 years ago. So back then, everybody has a compiler. We had a compiler on mainframe Unix system. We have Microsoft compiler. We have modern compiler. So everybody who developed software for the government had to go through the certification of their compiler. So right now we are in similar situation. Either people wrote their own training software or they bought some mathematical package that can help them implement training software, or they buy some training commercial off-the-shelf training software. So they are not unified yet.
Yes. No, that's a very good analogy from the past. So this actually will maybe pull on your background, Dr. Pham. The question is, to what extent is the FAA consulting with the DoD, Air Force, and NASA on AI development and implementation?
We are sharing what we're doing. Number one, even before the executive order asking us to work together. Before that, we share with those agencies mainly to make sure that whatever resource we have, we spend it wisely by not duplicating everybody else's effort. So by sharing the technology, we discover that we also share interest of regulation of AI. And now with the Biden executive order from President Biden, we see a stronger urge to collaborate. A few weeks ago, we had a meeting with NASA and we went through some of the collaboration and we agree on some of the things that we can work on for safety assurance of AI. In the past, I had conversation with NASA Ames Research Center on this topic, but now with the agreement between NASA and FAA, we can move further into specific tasks.
Great. And that is great to get insight on that. And we do like to hear about the collaborative efforts. So next question is deterministic, as in learned AI, the same as explainable and traceable? And actually, I'm going to make that a question. Is deterministic how you would define learned AI? And then is it the same as explainable and traceable?
In the beginning, when I joined the FAA, I heard a lot of conversation about uncertainty in AI, and it goes deeper into machine learning, and I can see where it's coming from. But what we are facing at is a simple project. I call that simple, but it's the simplest project that we could find with learned AI, where after training the model, we lock everything down to be static. And what it means is that it's very similar to the control law with specific input in. We know exactly what the output of that model, and that corresponds to EO 178C about when we have a model, we have to understand the behavior of that model, both intended and unintended. So with the definition of the model that we are encountering in this AI application, everything is static in terms of the weight constant that people try to evolve during training. After training, those constant will be constant fixed, and therefore the system is 100% deterministic. There's no worry about uncertainty on that model. But at the same time, that definition is allowing us to provide the understanding of the behavior with respect to DO 178C, both intended behavior where the input are within a well-defined safety range, and then the output is clearly understood. And at the same time, if the input are outside that well-defined range, what would we encounter in the form of unintended behavior? So with the deterministic model, we can establish both of those behavior for system integration.
Great. I appreciate that a lot. I'm looking, okay, we got time for a couple more questions. Here's one. Will the FAA also work on verification and validation of AI and ground-based decision support tools in parallel with the onboard AI systems, or would work on the VMV of AI and ground-based come later down the line?
The question is about how much resource we have. And I know that in the real world, nobody has unlimited resources.
Yeah.
And as you saw in the roadmap, we focus ourselves on onboard software, and with the qualifier that that's not the only thing that we want to consider. We just want to consider that at this point, and with the incremental approach, what we're hoping for is with the understanding of AI on onboard software, we can extend that to other domain.
Great. Okay, a really good question. I like, how can universities and the academic community support the implementation of the roadmap?
Right now, we have one university under contract for the AI effort, and we're hoping to have more, but the technology that we are talking about, even though it has been around for years, but the dimension of the data make it more complex. For example, we know how to analyze data to get the engineering characteristic of the final model. And then when I present it to the community, I often heard two questions. Number one, can we apply it to a very difficult problem with machine vision, where the dimension is uncountable, very large? And I said yes. But when I try to sit down and apply the analysis, I discover that it can run with data like 2 or 3 images. But the industry mentioned something in the order of 100 million images.
Yeah.
So that requires new technique with better computational efficiency, so that the computer that runs the analysis can finish within some finite time. And I think that's where the industry, the university can help. Another aspect is some of the things that DO 178 mentioned is the precision of the model. I know at the time, the precision might be about the computational hardware platform, whether it's 8-bit, 16-bit, or 32-bit on, but there is in this modeling aspect, we talk about precision in terms of the arrow of generalization. And the university can help us to establish the arrow and the bounds of the arrow that can help the us at the system integration level. So there are a lot of things that university can help. And I already had conversation with many university professors suggesting how they can help and how else they can do outside my scope. So I would appreciate the conversation to carry on with university professor.
Yeah, those were great examples of where that research then supports and helps.
Yeah.
Support your framework. Let's see. I just want to be sure. Okay, this is going to be the last question, which is the FAA also working with the United Kingdom and the CAA, the UK CAA, or other international regulators, other regulators for other jurisdictions on this topic?
That's a very good question. When I came over to the FAA, I was contacted by EASA, specifically my counterpart, Guillaume Soudan. So we began to have conversation about the direction of AI. And as soon as I figure out some of the aspect of AI, I began to have conversation with other regulation authority like the UK CAA. We also had conversation with the authority in the Asia Pacific through our international office. And we have close relation with ANAC and Transport Canada through previous software effort. So I took advantage of all the relationship and share the understanding of AI with everybody from the regulation side.
Great. Thank you for that context. I am sorry to say we are just about out of time, but like I said, Dr. Pham did say that he would review the questions and provide answers for the ones that are answerable, but also, as you saw, you can download the slides will be available, and this is being recorded to be rebroadcast. Before I get to housekeeping, I just want to thank you, Dr. Pham, for your time and the conversation. I look forward to listening to the next workshop you do in October and to welcoming you back on November 13th, where we'll do a day-long workshop and see what we can, solve all the problems of standards and AI. What do you think?
Thank you, Rebecca, and thank you, RTCA, for the opportunity to share what we have at the FAA. So we see an important aspect of collaboration is to share the understanding so that we can move forward together.
I appreciate that. Thank you so much.